ID, please use your real name following with your origin of institution. All of participants are expected to mute the audio and only unmute the video during the event. We cordially invite you to take your own firm and comfort seat in your own room and please avoid the backlight. Make sure that you have a good and stable internet connection. If you have an earphone or headset, we recommend you to use it so that your voice can clearly and loudly to be heard. During the Q&A discussion session, all participants, please use the chat box to deliver the questions. Thank you for your cooperation and consideration.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to the guest lecture series or GLS on SDGs today, Tuesday, October 12, 2021. I am Denti from ITS Global Engagement and I will be your master of ceremony for today's meeting. And today, thank you for joining our GLS on SDGs. And before we start our agenda, let me inform you of some rules for the event. First, please adjust your name or ID screen using format name_campus. Second, during the lecture, please turn off your microphone unless allowed by the moderator or the speaker. Third, please fill your attendance at bit.ly/GLS_attendance. And our committee has already sent the attendance link in the chat box as well. And for the participants who wish to get an e-certificate and STEM, please fill the attendance 15 minutes after the session starts. And last but not least, participants who wish to ask questions during the Q&A session, please send your question to bit.ly/GLS_Q&A. The link will be provided as well in the chat room by the committee. Or you can ask directly by clicking the raise hand feature. And today's GLS on SDGs will present a topic entitled Clean Water from Physics Perspective that will be delivered by Dr. Siti Nurbaya Supardan from University Teknologi Mara. And this lecture will be moderated by Dr. Ruri Agung Wahyono from ITS. And before we start our agenda, allow me to deliver our schedule today as follows. First is there will be an opening from the MC, and second, introduction to moderator and speaker. Third, the lecture session and will be followed by the Q&A session. And then there will be a certificate awarding session and the meeting will be ended by closing. And before we proceed to the next agenda, let me introduce our moderator first. So, our moderator is Dr. Ruri Agung Wahyono. He is the lecturer at Department of Physics Engineering. And for his educational background, he is graduated from Institute of Physical Chemistry and School of Photonics, Friedrich Schiller University, Jena, at 2020 with a degree Doctor Rerum Naturalium. And he also got his Master of Engineering and Bachelor of Engineering degree in ITS. And his past experience, he was an associate researcher at IPHT Jena for TAB and full-time researcher at the same institute for FAS. And he is currently a government official of Republic of Indonesia under the Ministry of Research, Technology, and Higher Education of Indonesia, of Republic Indonesia. And now, without further ado, let's proceed to the main agenda. Pak Ruri?
Yeah.
Hello, Pak Ruri. Yeah, good afternoon. Are you ready, Pak Ruri, to get our session today?
Yeah.
Okay, the time is yours.
Okay, can you hear my voice clearly?
It's actually a little bit noisy because
Yeah,
you can hear the background noise, but yeah, you
a little
can
bit.
still hear your voice. Yes, maybe we will wait for Pak Ruri to find the perfect place to guide our session today. So today's event will be talking about the 6 SDGs, which is the sustainable, sorry,
Yeah,
which is, yes, the clean water
yeah, it's a little bit better.
sanitation. Okay, thank you, Pak Ruri.
Yeah, sorry, just a little bit distractions from the outside construction work. So yeah, thank you, Ms. Tanti, for the kind introduction. So good afternoon, everyone. It's me, Ruri Agung Wahyuwono, and it's an honor for me again to come and to join the global lecture series in which we will listen to today's lecture, which is associated to the Sustainable Development Goals number 6. It is clean water and sanitation. And yeah, in particular, the COVID-19 pandemic has increased the need for clean water and to prevent infections. So while making this clean water supply more difficult for some remote areas and vulnerable societies, for example, to access clean water supplies. And today lecture, we are glad to have Dr. Siti Nurbaya Supardan from the University Technology Mara, and who will cover entitled Clean Water Perspective. Okay. And before that, I'd like to introduce you all a little bit about our invited speaker, Dr. Siti Nurbaya Supardan. Okay, yeah. So as you can also see on the screen, Dr. Siti Nurbaya Supardan earned her PhD from the University of Liverpool since at 2020, right? Okay, and since 2010, she has joined the University Technology Mara as lecturer, and since 2016, she has been a senior lecturer at the same faculty. Her research interest includes semiconductor materials and devices, oxide glass and ceramics, and X-ray photoelectron spectroscopy analysis. So basically, our background is the same. So it's in the physical chemistry directions. And Dr. Siti Nurbaya Supardan also has received some awards, several awards during her tenure at the University Technology Mara. And to name a few, an excellent service award from University Technology Mara in 2014, and a special award at Ford World Invention Academic Conference 2020 in Korea. And so, Dr. Siti Nurbaya Supardan, we are looking forward to your lecture. I saw Dr. Siti Nurbaya is already there.
Thank you, moderator, Dr. Ruri Agung.
Okay, yeah.
Can you hear my voice clearly?
It's clear for me, yeah.
Okay.
Great.
Now I will share the PowerPoint slide. Can you see the slide right now?
Yeah, it's appearing here.
Okay, Assalamualaikum and a very good afternoon to all respected lecturers and students and all participants. I'm Dr. Siti Nurbaya Supardan from School of Physics and Material Study, Faculty of Applied Sciences, University Technology Mara, Malaysia. Okay, it's a very great pleasure for me to have this precious opportunity as an invited speaker for guest lecture series GLS, right, on Sustainable Development Goals, SDG. Okay, so my topic today is about clean water from physics perspective. Yeah, so this is actually from SDG Goal 6, which is focused on clean water and sanitation. Okay, SDG, also known as the global goals, okay, sustainable development goals. Okay, so this is were adopted by all United Nations member states in 2015 as a blueprint or a universal call to achieve a better and more sustainable future for all by 2030. Okay, so all the target is should be by 2030. Okay, if you look at here, there are 17. Okay, 17 SDG. Are all integrated and interconnected. The actions in one area will affect outcome in others. Means that if, let's say, for one area to two areas, second area, third area, and so on, until 7 area, they are already actually interconnected to each other. Okay, so means that every action in one area will affect outcome in others, and that development must balance social, economic, and environmental sustainability. Okay, so this SDG address the global challenges that we face, okay, including those related to poverty, inequality, climate change, environmental degradation, peace and justice. Okay, this is all the key parameter that the global look at on this issue. Okay, so we know that clean water is still one of the biggest crisis today. This is the quite biggest issue that we face around the world, okay, around the globe. Okay, for today, goal 6, which is clean and sanitation. Okay, this is the target is actually to ensure availability and sustainable management of water and sanitation for all. Okay, this is the goal 6 target actually. Okay. So if you look at here, we have like 1, 2, 3, 4, 5, 6, 7, 8, yeah, or 8 target that we need to achieve by 2030. Okay, so if you look at here, 6.1, okay, so this is referring to safe drinking water for all. Okay, this is to achieve universal and equitable access to safe and affordable drinking water for all. Okay, so means that we need to have a clean and safe water. Okay, and if you look at 6.2, okay, this is sanitation for all. Okay, this is actually the focus to achieve access to adequate and equitable sanitation and hygiene for all. Okay, it's focused on sanitation and hygiene. If you look at 6.3, okay, this is focused on better water quality, which is to improve water quality by reducing pollution. You know that pollution is the main source of contamination, contamination for water contamination. Okay, so we have to eliminating dumping and minimizing release of hazardous chemicals and materials. Okay, and then for the 6.4 is about more efficient water use. So this is to increase water use efficiency across all sectors and to ensure sustainable withdrawal and supply of fresh water to address water scarcity and substantially reduce the number of people suffering from water scarcity. Okay, so that's the target that we need to achieve by 2030. Okay, and then 6.5, this is about the how we manage water resource management. Okay, so this is how we implement integrated water resources management at all levels, okay, including through transboundary cooperation as appropriate. Okay, and then to protect and restore water-related ecosystem. Okay, this is about the ecosystem, including mountain, forests, wetlands, rivers, aquifers, and lakes. Yeah. So this is the target that we need to achieve by 2030. And then we also need to expand international cooperation, yeah, and capacity by capacity building to support and develop the developing countries in water and sanitation related activities, okay, and programs. So means that we have to do like international cooperation and collaboration. Okay, and then the last one is to support and strengthen the participations of local communities in improving water and sanitation management. Okay. So this is the fact and figures that what happened currently. Okay, if you look at here, in 2020, billions of people worldwide still live without safely managed drinking water, sanitation, and hygiene. Okay, if you look at here, 2 billion people, around 26% lack safely managed drinking water. Okay, and then you can see 3.6 billion people, around 46% lack safely managed sanitation. Okay, and then 2.3 billion people, around 29% lack basic hygiene. Okay, so over the past century, we can see that global water use has increased at more than twice the rate of population as well. Okay, so this is you can see that 2.3 billion people live in water stressed country. So means that how water, the water issue, global issue become increased. Yeah, you can see here. All right. And then there are 129 countries are not on track to have sustainability managed water resources by 2030. Okay, so this is actually a current rate of progress need to double. Yeah? So we have to double our current rate of progress. Okay, so other than that, between 1970 and 2015, okay, natural wetlands shrank by 35%. Okay, this is actually 3 times the rates of forest loss. So this actually freshwater ecosystem and the multitude of resources that they provide are changing dramatically. Maknanya changing dramatically, and 1/5 of the world river basin are experiencing rapid increase or decrease in surface water area. Okay, so this is because of the problem that we face today. Okay, then you can see also the estimated around 1.2 million people die as a result of unsafe water sources in 2017. Okay, this was around 2.2 of global death. So this is a very serious problem. Okay, and then this is happened in low-income countries. Unsafe water sources account for around 6% of death. Okay, and then if you look at the statistic each day, okay, nearly 1,000 children die due to preventable water and sanitation related diarrheal disease. Okay, diarrhea disease is actually the second leading cause of death in children under 5 years old. Okay, so the intervention to prevent diarrhea, including we have to do like we need to have a safe drinking water, okay, use of improved sanitation, and also maybe we have to regularly hand washing, which so can also reduce the disease risk. Okay, now we move to the physics of water. So here I'm going to highlight the physical properties of water that make it so essential to life on our planet. Okay, so we need to know the properties of water. Okay, so as we know that a water molecule is very stable. It's very stable. So this is a polar molecule, which is it has a negative and positive at the end. At the end of the, if you look at here, at the end we have a negative and positive charges. Okay, so this actually have an unequal distribution of charges on the water molecule. So this is due to the different electronegativity values. If you look at here, we have oxygen. The value is around, if I'm not mistaken, is around 3.44, the electronegative values, and then hydrogen is 2.2. So the different value of electronegative value makes that it becomes the polar molecule. Polar molecule. So
Dr. Siti Nurbaya, may
yes.
I interrupt a little bit because the slide is not moving. So it remains in the physics of.
Okay, all right. Okay, can you see?
Yeah, now it's.
Okay. So this is due to the different electronegativity values of oxygen and hydrogen atom. Okay, so oxygen has two lone electron pairs that repel each other, and the electron bonded to H atoms, which is hydrogen atoms. Okay, so it gives the band shape around 104.5 degree. If you look at here, okay, oxygen and hydrogen, they has a band. So band shape, we call it as a band shape that make it a polar molecules. Yeah. So if you look at here also, H bonds, hydrogen bond forms between the partially negatively charged oxygen atom. Okay, so it means that oxygen atom has a partial negative charge. Okay, and then between and also we have a partially positively charged at hydrogen atoms. Yeah, hydrogen atoms. So this hydrogen bond will give water as a unique properties. Yeah, in terms of the property, it will be very unique due to H bond, hydrogen bond. Okay, so unique properties of water. Okay, so we know that water is a universal solvent. Okay, so means that it can dissolve many substances. Yeah, so this is due to polar molecule. Water is a polar molecule, as I said before. So with one end more positive and one end more negative. Okay, so when it's being polar, that's allow water to dissolve nearly any substance, any substance with an unequal distribution of charges. So because of the polar properties, then make water become universal solvent. Yeah? It can dissolve many substances. Okay, and also water is the only substance which exists under normal conditions as a solid, as a liquid, and as a gas. So there are three phases: solid, liquid, and gas for water. And then if you look at the density of ice, is less than the liquids of water. Okay, so the value you can see from my slide, 0.915 gram for density of ice, and then liquid water is 1 gram per centimeter cube for liquid water. So because of the density of ice is less than liquid water, then we can see that ice floatings, ice floats. Okay, and then the other properties of water. It has a high cohesions and additions. Yeah? So cohesion is the attractive force between water molecules. Okay? The attractive force between water molecules. And then the additions is a tendency of water to stick to other substance. Okay, so means that they have a high cohesion and additions. So it makes that H2O or water sticks to itself, causing surface tension. Okay, you can see that in the picture there will be a water forms droplets. So this is due to high cohesions and additions. And then it also has a high specific heat capacity. Okay, and then so this is due to high energy required to break H bond, hydrogen bond that hold the liquid together. So this is a very this value of high specific heat is good to maintain the temperature, especially in the lake. Okay, right. So the other properties of water is also exists as a liquid at room temperature. Okay, at room temperature, water will be a liquid. Okay, now we move to what is the importance of water. Okay, so we know that water is an essential commodity. Okay, that is very important for human life and all life on earth. Yeah, so maknanya dia sangat penting. Water is essential commodity. Okay, a person can live about a month without a food, but only a week without water. So it means that if we don't have enough water or lack of water, so it will give a problem to us as a human, because we need water. Okay, water is life. All living organism need water. Okay, water is a major abiotic factor in the environment. Okay, and then it's almost all activity of life support system. So we need to use water in our life, in our almost all activity of life support system. For example, all domestic purpose like agricultural, industrial application, cleaning, and recreation. We need water. Okay, and then about 3/4 of the Earth's surface is covered by water. So around that values, 97% of world water is in the seas and ocean. Okay, so this is considered as a salt water, and only 3% is present on the continent as a fresh water. So if from the value of 3%, only 1% is usable. Means that we can consume only 1% from fresh water. We can consume only 1%. So it may seem like water is abundant because you see that 97%. But the fact that only 1% is suitable for consumption. Okay, so that's why we need to reuse or recycle water by having a sustainable wastewater treatment to protect our constant freshwater supply. Okay, and then our bodies are also composed of and dependent on water. So for human, basically is around 70%. Our body is made up of water. So this is how important water, for human being. Okay, so and then if you can see here the pictures, water serves as a number of essential functions to keep us all going. So you can see that how water can how water can regulate our internal body temperature. Okay, by sweating and respiration, and so on. Okay, you can see from this figure. All right, and then the drinking water should be totally clean, pure, and free from any contaminants. So this is the definition of importance of water, where we have to get the water need to be clean, pure, and free from any contaminants. Okay, clean water can be defined as a safe water. Basically, when we say that clean water should be related to safe water. So based on the United States Geological Survey, okay, we say that water that will not harm you if you come in contact with it. That's the definitions of clean water. So it also can be related to drinking water. Drinking water means that the water is safe to be drink, so potable water, and for all domestic use. Okay, so domestic use such as for indoor and outdoor household purpose. Okay, let's say like that we do, the water that we need to clean our household purposes. Okay, now we go into water quality. How we can say that the water is in high quality. So this is actually we need to measure of the conditions of water relative to the requirement of one or more biotic species and or to any human need or purpose. So there are 3 parameters that we look into to ensure that the water is in high quality. So this is like physical properties, chemical composition, and biological properties. So if you look at for physical properties, there are certain criteria that we need to look into is, for example, like temperature. Temperature, even temperature is not directly used to evaluate whether water is potable or drinkable, or not. So actually, this is very important in natural water system, like lake and rivers. So the criteria of temperature is very important. Okay, and then the other one is about the color. So we know that pure water is colorless. is colorless. So if we look at the water, there is a color, means that there will be a contamination. That might be there is a pollution. So color of water is due to the suspended particles and organic matter. Okay, for example, you can see that brownish color in water might be due to presence of iron. Okay, maybe okay, and then if you look at greenish water, greenish water, a greenish color in pond water, maybe it due to the microorganisms such as like alga. Okay, and then you can see also how the physical water including the taste and odor, and then turbidity and also electrical conductivity. So we know that water is a very poor electrical conductivity, which is it cannot conduct current. Cannot conduct current. Okay, and then in terms of chemical composition, we will look at into the properties of pH, and then total dissolved solids, major ions, minor or trace element, hardness, salinity, or alkalinity. Yeah. So pH is actually pH is actually to indicates the concentration of hydrogen plus, or we can say that this is a hydrogen ion. Where the lower the pH, the more H plus. Maksudnya di sini, if we have a lower pH, lower pH, less than 7, for example, because 7 is the neutral pH. Neutral pH, or we call it as a pure water pH, is around 7. Okay, if we have a lower pH, means that the more hydrogen ion. So if you basically for pure water is neutral, okay, with a pH close to 7 at room temperature at 25 degrees. So the safe range of pH that we can drink, I mean for the drinking water is usually around 6.5 to 8.5 for domestic use and living organism. Okay, that's how important the pH value for determine the water quality. And then we will look at into other parameter, which is the biological properties. Okay, and here we will see there is a certain area. For example, how the water quality is it affected with the other microorganism, okay, such as like bacteria, algae, viruses, and so on. Okay, so means that for water quality, for pure water, so it should be has a criteria of colorless, tasteless, odorless, okay, and then it also very clear and do not absorb light, and then also very low conductance. Okay, so that's water quality that we can see. And then we go into contaminants in water. So what is contaminants? So this is actually undesirable substance in a solution. Okay, that's the definitions that we can say about the contaminants. So if we have an undesirable substance in a solution, it means that the water will be quite contaminated. So the contamination level, it will depend on the water quality. Okay, and then drinking water that contains contaminant can be hazardous to both plants and animals. So that's why we need to drink water that safe drinking water. Okay. There are few key industries contributing to water contaminations around the world. Okay, the main sources is from agricultural activities. This is a very huge contributor to water pollution. Because we can see that such as like herbicide, pesticide, and fertilizer from agriculture, toxic chemicals, and heavy metal as well. Okay, and then other things is biological contaminants are organisms, okay, that live in the water. For example, like bacteria, salmonella, E. coli, parasite, and so on. Okay. Okay, this is the solution that experts have proposed, a fourfold path toward a viable solution for making water both potable and safe. Okay, there are a few criteria, such as like seek new sources. Okay, so it means that we can extract fresh water from ocean salt water. Okay, and then we have to save and redistribute supplies. Okay, reduce demand, and also we have to recycle or reuse. So it means that wastewater can be reused and hence can be conserved. Yeah, so it means that we have to look at on this solution, how to conserve our water. Yeah. Okay, now we go into water purification methods. Okay, there are several methods that we can use to purify water, to get a clean water. Okay, such as like sedimentation. Okay, so sedimentation is actually the process of allowing particle in suspension in water to settle out of the suspension under the effect of gravity. So we need to have the process to allow particle in suspension in water, okay, to settle out of the suspension under the effect of gravity. Okay, and then other method is by using filtration. Okay, filtration is actually the process used to separate solid from liquids or gases using a filter medium. So this can allow the fluid to pass through but retain the solid particles. So I mean this filtration is a common method that we use in our water purification. Yeah. Okay, and then we have also chlorination, okay, and then ozone bubbling, okay, and then distillation, adsorption, ion exchange, reverse osmosis, okay, and then ultraviolet, and also photocatalysis. Okay, for today's session, I will talk more on photocatalysis because this is part of my research work. Yeah? So I will discuss more on photocatalysis as a method for water purification. Yeah. Okay, now we go into, we can see here water treatment plant. This is the example. The picture shows the water treatment plant in Malaysia. Okay, so there are several process that water, or we call raw water, need to be go through to have the clean water that can be used for consumer. So the method is include coagulation, okay, flocculation, okay, sedimentation, okay, and then also disinfection. Okay. So if you look at here, coagulation is a step in which chemicals are added. Yeah? So that means that we have to put coagulates in water. Okay, we have to add small particle suspended in the water to clump together. Okay, so coagulants are added to the water prior to sedimentation in order to facilitate the settling process, which is followed by filtrations and other treatment steps. Okay, so next we go into flocculation, which is the step is to mix the water with large paddle so the coagulated particles can be brought together into larger clumps, or we call it as a flock. Okay, so that's only settled on the bottom of the tank or basin. If you look at here, so it means that first step is coagulation, and then flocculation, and then it goes to the go into sedimentation. Okay, sedimentation is the step that we use to purify the water, while allowing remaining particle to settle. Okay. So after that, the process after sedimentation is a disinfection. Okay? So during disinfection, we have to go through first the filtration, and then after that, it goes to treated water storage. Okay? Disinfection is the final step. Basically, it's the final step in water purification. Okay? During that step, harmful microbes such as like bacteria, viruses, and protozoa are killed through the addition of the disinfectant chemicals. So basically during this step, it involves a form of chlorine. Yeah? So we have to add chlorine, yeah? especially like chloramines or chlorine dioxide, yeah? For example. So actually to clear the water. Yeah? All right. So then after go through the inspection, okay, the treated water will be distributed to for home consumption. Yeah? Okay, this is several methods that already used in Malaysia for wastewater treatment. Okay, there are 3 different methods, which is a physical unit operation. Okay, this method actually for the treatment method that use the applications of physical forces to treat sewage. Okay, this is basically will go through screening, mixing, flocculation, sedimentation, filtration, and flotation. Okay, after a physical unit operation, they will go to chemical units, which is for chemical units we have to remove or convert pollutants by additions of chemicals. Okay, so this technique, for example, they use a precipitation, adsorption, disinfection, and chlorination. Okay, so this is basically under chemical unit. And then biological unit. So this is to remove pollutants by biological activity. So for example, microorganisms such as like bacteria, okay, is used in the biochemical decomposition of wastewater to stable end product. Okay, so this is the 3 different methods that Malaysia has been used for wastewater treatment. Okay, now about UV radiation. This is just a basic concept about the UV radiation. Okay, we know that UV radiation is the portion of the EM spectrum. Yeah? We know that EM spectrum has a different we call different range. Yeah? So we have UV here. We have a different range that can categorize into 4 regions. Yeah? We can have a long wave UV, okay, or near UV. Yeah? So this is called as a backlight. Okay, this is around 350 to 400 nanometer. Okay, and then we call it as a UVA. And then we have also UVB. Okay, UVB is the middle wave UV. Yeah? So this is around 280 to 350 nanometer. And then we also have a short wave UV. This is around 200 to 280 nanometer. And then the last one is a vacuum UV. Okay, this is called as a VUV. Okay, so this is less than 200 nanometer. Okay, so at UV range, this is usually will be used for water purification. Yeah? So we know that based on the interactions of wavelength of UV radiation with biological material, okay, so there are 3 divisions. Yeah? You can see here: UVA, UVB, UVC, and VUV. Okay, now I move to photocatalysis. Okay, so the words of photocatalysis. Photo means that we need light, light photo. Okay, and then catalysis is the how we want to accelerate a photo reaction in the presence of catalyst. Yeah, so we need to use catalyst, okay, to accelerate the photo reaction. Okay, so in here, this is one of the advanced oxidation technology for the removal of persistent organic compound and microorganisms from water. So this is one of the best advanced oxidation technology. Yeah? So it started from 1972, where Fujishima and Honda demonstrating the use of TiO2 for the photoelectrochemical splitting of water using UV light. So they use the UV light. Okay, and further for the generation of charge carrier in TiO2. Okay, TiO2 is the very good catalyst, good catalyst for photocatalysis. Okay, room temperature reaction. This is the advantage of photocatalysis, which is we can operate at room temperature reaction, okay, low or no chemical consumption, and no waste sludge production during the treatment, and minimal operation cost. Okay, this is the criteria that we need. Is the cost is very minimum. Okay, so the most widely used photocatalyst is titanium dioxide, TiO2. Okay, now about the mechanism of photocatalysis. We know that photocatalysis involves excitation, diffusion, and photo-induced charge carrier. If you look at in the figure here, okay, you can see that semiconductor photocatalysis happen when we have the photocatalyst. Okay, when a semiconductor photocatalyst such as like titanium oxide or zinc oxide and so on, absorb a photon. Photon is the light from light, okay, sunlight, that has a higher energy than its band gap. So the criteria is higher energy than its band gap. Okay, so what happened is the electron hole pair are generated. Okay, so this is basically what we can say that electron hole pair is formed when an electron in the valence band. So we can see that electron in the valence band is excited to the conduction band when it absorbs the photon, which is higher energy than its band gap. Okay, so when the electron hole pairs are generated, these photo generated holes and electron diffuse to the surface, diffuse to the surface, and then they will oxidize and reduce oxygen and water molecules. If you look at here, electron, excited electron will reduce the oxygen through the reduction process to give the superoxide. And then a reactive radical O2, which is the reactive radical, which is O2 and OH, OH radical and O2 are created and will decompose organic and inorganic compound. So if you look at here, the hydroxyl radical are formed when the superoxide ion react with proton, or when water molecule react with an electron hole pair. So they will have a hydroxyl radical. Hydroxyl radical, when it combined with the organic compound, it will release the carbon dioxide and water molecule. So this is how mechanism of photocatalysis happen. You can see in the figure. Okay, now we go into TiO2 based photocatalyst. We know that TiO2 is the most common studied photocatalyst. This is because of the advantage of low cost, availability, and also non-toxicity. However, there is a problem of TiO2 because TiO2 only can active in the UV region of the solar spectrum, which is only 4% of the total solar spectrum. So means that we need to extend the region to visible region. So this is actually to reduce the electron hole recombination, and then also in order to extend the light absorption to visible region. So there are several approaches to improve its photocatalytic efficiency. For example, by doping TiO2 with different transition metal ions. So transition metal ions such as like copper, cobalt, nickel, zinc, chromium, iron, and so on. So other than that, we can also doping TiO2 with dopal metal, noble metal, and then also non-metal. And then we also can do several approach by do a semiconductor coupling. In here we can use like TiO2 and zinc oxide. And then we also can do a co-doping. When we, for example, we use a different transition metal ion, for example, with non-metal ion. For example, nitrogen and fluoride, copper, we call it a co-doping. And then also we do a surface modification. And then this is quite latest technology, advanced oxidation process. which is using a graphene-based TiO2. Okay, so we know that graphene is has a large surface area, which makes it a good absorbent for organic pollutants. For organic pollutants removal. So this is a quite good material, okay, that can be explored to do with TiO2 as well. Okay, now as a conclusion, what I can say here, based on what I explained, we know that water very essential for human life. That's why we need to make sure that our water need to be fresh, clean, and safe for be consumed for us. That's all. Thank you very much.
Okay, thank you very much, Dr. Siti Nurbaya, for the nice talk that you have given to us. So now it's time to the Q&A sessions. So I will open the Q&A sessions, and yeah, if the participants here have questions, please, you can also raise your hand and ask directly to Dr. Siti Nurbaya, or you can also fill the link that is sent to the chat box, and I will read your questions there. Okay. Let me check first if there is questions from the participants. Okay, then let me ask something to open the discussions with you. So in your presentations that you mainly focus on the photocatalysis for wastewater treatment, you just mentioned that titanium dioxide is the most commonly used materials, right, for photocatalysis.
Yes. Yeah.
And there is another, for example, zinc oxide also has this kind of similar electronic properties to the titanium oxide, right? So the band positions and also the optical band gap, but it possesses more defects on the materials than titanium oxide. But in your point of view, just to open discussions with the students here, what is the key materials properties that for catalyst or photocatalyst in general that enable a wide spectrum of organic pollutant degradations? Because as we know, organic pollutants can be some normal organic molecules, but there is some molecules that contain, for example, azole groups, yeah, in the chemical structures, which is hardly degradable using photocatalysis. So
I think thank you very much, Dr. Rudi Agong. So I think the best properties that we need to look into the material that's suitable to be used as a photocatalyst. I think you have to need to look at the in terms of its optical absorption. For example, it must be quite strong. Need to be strong optical absorption. And then in terms of the stability, it need to be high stability. Okay, and then also we have to look at the band gap as well. So because we know that photocatalysis will be look at into the band gap, because we need to excite the electron from the valence band to conduction bands, right? So we need to have the suitable value of band gap as well. So we have to make sure that the band gap is not too large. If it's too large, then it's hard for electron to jump into the conduction band. Okay, so that's the criteria that we need to look into. And then other than that, we have to make sure that in terms of the what we call the chemical properties, in terms of the photostability, in terms of the photo corrosions, is also need to be quite good. That's why I said that graphene also can be replaced to be one of the good photocatalysts because it has the what I say that it has a good absorbent, okay, and then it also has a large surface area, okay, we have to look at into the surface area as well. Okay, thank you. Is there any question?
Yeah, I'm also waiting for the participants to ask something, probably related to materials. This Hanifuddin, I think it's Mr. Hanifuddin. Harifuddin, sorry, yeah, this. Mr. Harifuddin, could you unmute your microphone first?
Okay. Yeah, thank you very much. My name is Harifuddin from ITS Marine Program Magister. So I would like to ask question to Bu Siti Nurbaya. Yeah, quite interesting your presentation about this water treatment. So in the water treatment, there is process we call chemical unit. As understand that the water we try to drink the water which is free from the chemical, but in the process there is process. In this process there is the chemical process. So what about this chemical process to result the water which is we can drink safely according to the water standard? Thank you.
Actually, this is not really my expertise in the environment technology. I'm more to material. Maybe if someone quite good in this area, maybe can discuss together here about the quality, right?
Yeah, I think what is asked is what kind of chemical process involved for drinking.
Yeah, I mean in the water treatment process, there is a state we call a chemical unit. Means we have to, in the process they have to inject some water chemical. So in the other hand, we have to drink the water which is no chemical inside, because its chemical is normally is dangerous to the people, to the health. So this is quite I mean this is process quite opposite from what we need from the water. Thank you.
That's a very good question. I think I will go in detail because I'm not really sure about the answer. What is the value? I mean, according to the standard, right? You asked me about the standard value, right? For
yes.
The standard value to determine the water quality.
Yes, what the quality? We inject the chemical to the water. So what the level of the water that safe? What content from the chemical? Then we can say this is water is safe to drink.
I think I will get back to you later because I'm not really sure about the answer. But I know that in terms of the color and pH, I know a little bit about that one. So in terms of the color drinking water, maybe it's, I think if I'm not mistaken, it's around 15 CTU, right? For the acceptable drinking water, the value of, I mean the guideline value for drinking water is around 15 CTU. CTU is a true color unit, if I'm not mistaken. This is based on color, but I'm not sure about the value regarding to the amount of chemicals, the standard value.
I also want to add something probably. Just
thank you.
You already presented there that there is a several steps in processing of drinking water or wastewater treatment, for example. But if the water treatment is for drinking water, for example, here in Indonesia, for example, in like a drinking water company, which is state-owned company, also use chlorine gas injections in the chemical processing unit. But there is a certain standard. What is the maximum concentrations of chlorine or excess chlorine in the water that we can use for drinking water? And if I remember correctly, it should be maximum 1 to 2 part per million of chlorine gas. But I'm not really sure again. But you need to really check again what is the standard for maximum chlorine unit. But it's probably different from company or from one country to another country. that's one that I want to add something from your explanation.
Thank you. Thank you very much for the explanation, Dr. Ruby.
Okay. Any follow-up questions, Mr. Harifuddin?
Thank you.
Okay. Yeah, thank you very much. Now I have another questions from the participants here. It's from Mr. Alfian. I suppose it's Mr. Alfian Rizky Maulidan from ITS Surabaya, from the Department of Industrial and from Department of Industrial and System Engineering, and he would like to ask. I just copied the questions. Here is the use of photocatalysts quite commonly applied in today's big industry, and what are the future development prospects of this technology?
Okay, regarding the photocatalysis, right? So photocatalysis is very common technique or method that used in to purify the water. So this is a very permissible method that can be used. Okay, in terms of the future prospect, I think this is also a very promising technique, because we can use a different kind of material. It's not only a TiO2, maybe a graphene oxide, okay, as a photocatalyst. So this is very promising method actually for me, yeah, from my point of view.
If we ask in terms of, I mean, like in light of like in industrial applications, for example, in Malaysia, could you share also some information to us that this particular photocatalytic technology is already used, or it's already measured? The technology is, I know technology is still under development, but
yeah, still under development, still under research. Yeah, I think for the time being, I think they still use a reverse osmosis, right?
Yeah.
Reverse osmosis. Yeah. That's the best method as well.
Yeah, and also some industry might use like an adsorbent or something like that to just.
I think this is not for the large scale. Maybe in the low scale. But in the future, maybe we can apply this technique for the, for the larger scale, hopefully. Yeah. Is there other question?
Yeah, there is another from, I suppose it's Miss Natalia Fabarova from University of Pardubice from Czech Republic. So the question is, let me read the questions here. Yeah, water is also important commodity in industry. So should we also think of how to recycle water, not just for drinking, but also for industry, if it is needed in many processes there? And are the technologies and limits the same? Because I guess the allowance of pollution or pollutants here can be much higher for industrial water than drinking water. So that's questions from Miss Natalia.
Right. In my opinion, I think for industry, we need to look into a different method, different method that can maybe we can see that is there any method that we can use for example, for agricultural, for example, how we want to reduce the level of pollution. So we have to look at into different method. For example, that I already mentioned before. If you look at here, there are several methods. Can you see here? Okay, there are several methods that always used for the large scale. For example, ion exchange, reverse osmosis. Okay, this is that we can go into for industrial maybe. Yeah. Is it okay, the answer?
It's responded by herself. So thank you for your kind answer. So is there any, I mean, like in your experience, what is the difference between the quality standard of water, for example, for drinking water and also for industrial water, for any intake of process?
Okay, for industrial, might be the value will be different for drinking water in terms of the quality. For drinking water, it should be, as I mentioned before, you will get into the, for example, the pH, yeah, for drinking water, it should be around 6.5 to 8, for example. Okay, maybe for industry, it might be not too, I mean, maybe the range is within that value, but not too, you know, not very, very pure, yeah. Because for drinking water, we have to make sure that it's safe, yeah, it's safe and also very in terms of the cleanliness, and then in terms of the purity, it should be, we have to take into consideration, yeah. I think for the industry, might be it's good that we can use to recycle, water recycle, okay, or maybe we can use reuse water.
Here another questions appears from somebody who cannot be mentioned the name. That's from ITS, also from the Industrial and System Engineering Department. So the questions was to test or maintain water quality in rural areas. So which water treatment is the most suitable for maintaining water quality?
Maintaining water quality in rural area.
Or yeah, which water treatment is the most suitable for maintaining water quality in rural areas?
I think we cannot say that only one method that can be used. Yeah? So usually they will mix the technique of water purification, isn't it? For example, sedimentation, filtration, and chlorination. Okay, they will involve lots of methods. It's not only focused only on one method.
Yeah. Okay, and probably yeah. If somebody, I mean, like, just think that in a physics point of view, I mean, like, somebody might think of which physical properties that you have already mentioned that are considered the most essential parameters to assure that the water is clean, either for drinking or sanitation. Would you mention some, or no? Every parameter is essential.
Yes, every parameter is essential. Yeah.
Only for clean water, for drinking, right? Or
yeah. You need to consider all the properties.
Yeah. Or is there any simple assessment protocol basically for clean water? Or could you suggest what? I mean, like, if someone's stranded somewhere else, I mean, like, what could you suggest an instrument that is minimum required for assessment for clean water? I mean, like, or how to make sure that the water is clean without any instruments, something like that.
For me, you can see from your naked eyes. Yeah. From your naked eyes, you can measure that either the water quality is good or not. Okay. So based on your naked eyes, you can say that from the color. Yeah? So clean water, usually they have a color. I mean, in terms of color, is colorless, okay, odorless. Yeah. So you have to look at in the properties of water first. Okay. But I think most of you already have a filter. Filter water at home. So I think not so worried about it.
Yeah, that's true. Is there any questions from the participants here? I think we still have a lot of time.
Yeah.
Or probably you can also share again your talk. There is something that I want to discuss.
Sure.
Yeah.
Which part?
There might be students from physics or from chemistry or from materials engineering who wants to discuss something related to materials development for photocatalysis. Is it already shared? No, I could not see that.
Sorry. This is okay. Can you see the slide?
No, not yet.
Just a second.
Yeah.
Yep.
This probably to the photocatalytic process.
Mechanism, isn't it?
Yeah, mechanism of photocatalysis. Yeah. Yeah, from this, I mean, from this diagram here, right? I mean, like the goals for photocatalysis here is to produce these reactive radicals, right?
Yeah.
This will be used for a degradations of organic, or here you also mentioned inorganic compounds in water. But here, if we look at the energy diagrams of the photocatalyst, there is also recombinations there, right? Either this should be geminate recombinations, right? So if we talk about the future research directions of photocatalyst development, so in your point of view, so how should the materials be engineered to get like the minimum recombinations, high surface area, and also probably high defects, because the defect is the catalytic center for the reactions there. And yeah, because you already mentioned there are a lot of options to improve the quality or the performance of, for example, titanium dioxide. There are kind of ways, for example, by creating heterojunction between titanium oxide with other semiconductors, for example. Here you already mentioned that there is possibility to combine titanium dioxide with the zinc oxide, also dope with graphene, for example, or other carbon nanomaterials to improve the electronic mobilities inside the materials, and noble metals, for example, if we want to use a plasmonic resonance characteristic of noble metals. And yeah, in your point of view, and in which direction should be the development of photocatalysts for water treatment especially?
Okay, thank you, Dr. Ruby. For my opinion, I think if you want to find a suitable material for photocatalysis application, especially, so the criteria that you need to focus is on the band gap, usually band gap. Because we know that TiO2 is a wide band gap, it's around 3.2. Okay, so when they have when it has a higher band gap, wide band gap, so this actually will make the absorptions of photons is around UV region, UV region, as I said before, right? So in order to extend the region of photocatalysis activity to be more efficient, we have to consider the band gap, which is maybe is possible to get the value with lower band gap, lower band gap. So lower band gap, you will have when you have a lower band gap, you will have I mean, in terms of the region, they will go to high region, which is we go to UV to visible region. Okay, that's the main focus of photocatalysis, that we can also use visible region. Yeah, visible region means that because we know that a solar light, okay, most of the I mean, in terms of the solar light, mostly is on a visible region. I mean, that's why we hope that we can extend the wavelength into visible region. Okay, that's why we need to modify TiO2, and we have to dope. We have to dope with other material. So, for example, that I mentioned before. Okay, I think I already mentioned in the slide here. Okay, it's possible to doping with a different transition metal ions. Okay, so this is an example. Okay, then this is the criteria that we need to go through, that we can extend the UV region to visible region, and then also we can reduce the electron hole recombination. Electron hole recombination. That's the criteria that we need look into when we want to choose the suitable photocatalyst. Other than that, we also need to consider the low cost. Low cost is very important things that we need to consider. Okay, let's say if you find other material, for example, like rare earth materials, for example, like thulium oxide and so on. So you have to consider what is the price of the chemicals, of the photocatalyst. Okay, so that's why I said that you have to consider the cost as well when you look into the material of photocatalyst. Any question, Dr. Ulvi?
Yeah. Do you think that tungsten trioxide, for example, is also? I mean, like I'm also working with tungsten trioxide.
Sorry. What material?
Tungsten.
Tungsten. Okay.
So, and also some like molybdenum sulfide, tungsten disulfide, and something like that.
Yeah, I already read about the molybdenum sulfide. This is quite a possible material also that we can use as a photocatalyst as well. Sulfide, yeah.
Okay. And do you think recyclability of materials also important for photocatalytic process? I mean,
yes, yeah.
Yeah, I mean, like once it's used for photocatalytic degradations process, sometimes I mean, like the surface properties also already altered, right? So that's why it's not quote unquote reactive anymore to molecules, but some materials can also maintain its surface reactivity. So is there any, I mean, like I'm not really sure if somebody already, I mean, like work on that directions of recyclability of the photocatalytic materials, or is your group also working on these directions as well?
Actually, we work on this just recently because previously my work on gallium nitride. If you look into my details, I'm work on gallium nitrides on for MOSFET application. Now I move into different material, which is more focused on photocatalyst, which is now I'm focusing on TiO2. Okay, and then other than that, maybe we can try different. It's not only TiO2. Maybe we can try different oxide. For example, zinc oxide is possible as well. Zinc oxide, but I think TiO2 and zinc oxide is already stable. Yeah, I mean in terms of research study. Okay, so but currently, if I'm not mistaken, okay, graphene based TiO2 is the best one compared to, I mean, graphene base, carbon base. So they use a graphene oxide.
Not the reduced one.
Yeah.
The reduced one or the graphene oxide?
I can hear you. What?
The reduced graphene oxide or just the graphene oxide itself?
Reduced graphene oxide should be fine as well. Yeah, reduced graphene oxide and also graphene oxide. Then the other that you can also can try different surface modification. For example, you can go into I mean into nanofiber. It's possible as well. My work actually on nanofiber now. Yeah.
Ah, okay.
So means that instead of nanoparticle, I will fabricate the photocatalyst in terms of nanofiber. So because of the large area, in terms of the area, surface area.
Okay. I hope our discussions also attracts another questions.
I think you're still also in photonic, right, Dr. Ruri? Photonics, yeah.
Yes, and my job is basically to develop photocatalysts as well.
Oh, okay, I think it's quite good. Maybe we can collaborate.
Yeah, sure.
In research especially. Yeah.
Okay, any other questions from the participants? We have already half an hour.
Yes.
So yeah, that would be great if we can also collaborate in the development of photocatalysts. I'm also working on titanium-based and zinc oxide-based photocatalysts, and in combinations with several carbon allotrope. Yeah, it's not only graphene, and also carbon nanotubes and fullerenes and some.
That's a very good material as well to be explored. Yeah.
Okay, then if this is not the case, then yeah, many thanks again, Dr. Siti, Nurbaya, Supardan, And yeah, as a brief conclusions that I could extract from the guest lecture series today, that yeah, in the beginning of the talk, Dr. Siti Nurbaya Supardan already mentioned, and I highlight that we only have like 1% usable water resource in the world, and the clean water is considered as an important resource that in the future can be extracted from either seawater, can be processed from recycling, and also in a point of view to reduce water consumptions. But yeah, here also amongst various available wastewater treatment, for example, in light of recycling, yeah, we already discussed a photocatalytic process, and in the directions of material development for photocatalysts. So some properties that need to be considered important to the development include some like a higher surface area, wide absorption, visible light absorption, for example, because we want to move to a higher light flux from the solar spectrum, which is in the visible light spectrum, to have appropriate band gap levels. It has a high photo stability, and also last is the recyclability of the photocatalyst materials. And yeah, that's all that we need to discuss. Thanks again, Dr. Siti Nurbaya Supardan. It was a nice discussion with you. And yeah, I now hands again the sessions back to the MC, Ms. Tanti. Yeah, thank you very much. And yeah, good afternoon, everyone.
Good afternoon. Thank you, Pak Ruri. Thank you very much, Dr. Siti Nurbaya, for the excellent lecture today, and Pak Ruri for guiding us through this amazing session. And please give a round of applause to our speaker and moderator by using the Zoom reaction feature. Okay, thank you. And furthermore, we would like to present a certificate awarding to our speaker and also our moderator today. Maybe the committee can help me. Yeah, this is the certificate for Dr. Siti Nurbaya Supardan. Thank you very much for your lecture. And next,
for this opportunity.
And next we have certificate for Dr. Renat Ruri Agung Wahyuono. Thank you very much, Pak Ruri.
Yeah, my pleasure. Thank you very much.
Thank you. And once again, thank you very much to our speaker and moderator for your availability on today's guest lecture series. And we believe that your lecture will be useful for all participants. And now, before we end our lecture today, we invite all the participants as well as the honorable speaker and moderator to take a group photo. And to all participants, please open your camera. And as we have around 8 slides, please keep smiling until we finish the photo session. Maybe for the committee, that will help me to take the documentation. Okay, I will count from 1 to 3. From the first slide, 1, 2, 3. And for the second slide, 1, 2, 3. For the third slide, 1, 2, 3. And for the fourth slide, 1, 2, 3. And for the fifth until 8th slide, because all of the participants are off cam, so maybe we can take the picture later. And now we have finally finished the group photo. And I will remind for the participants, please fill the feedback form through the link bit.ly/feedback_GLS that you can also see on the Zoom chat room. And the deadline for filling the feedback form is 1 hour after we finish this session. And also, the participants who will get the stamp are the participants who come on time to join this event until the end. And also fill the feedback form. So please make sure to fill the feedback form. And for the next week, we will hold another interesting topics into different stream. Maybe the committee can help me to share this screen. Yes, for the next Tuesday, we will have another topic about SDGs number 7. And there will be Professor Susana Yusuf from University Technology Petronas that will be delivering a topic about lab to pilot, thermochemical conversion of biomass to biofuel and material through green processes, and Associate Professor Hidetaka Kawakita from Saga University that will be delivering a topic about material preparation and separation of useful compounds from microalgae. And next. Okay. And finally, we have reached the end of today's guest lecture series, and we sincerely apologize for any mistake we may have made in presenting as Master of Ceremony and Committee. Thank you very much to our honorable speaker once again and moderator, and all the participants for the attention and cooperation. And we hope to see you soon in other events in the future. And please do not forget to follow our social media on Instagram and Facebook, ITS International Office, and keep updated of our programs. Once again, thank you. Good afternoon. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.